Hello, Dr. Mike here. This is for my CIS-2640 Network Security / Security Plus course, and this is Topic 6 of the new series, version 2 here, on Network Fundamentals, Infrastructure Security. It is off Chapter 2, which is basically Network Fundamentals, Infrastructure Security. It's a chapter of the same name, Chapter 2 of the current textbook. This is some really basic stuff here, and understanding the topology might be a review as you come into my course. Definitely good to review. Network is still the primary area of defense. OSI models. So the chapter is really good. I cover the basics. I'm not going over a lot of it here because my previous video, which usually I would link above, I'm actually just going to go ahead and splice right into it right about here. So there's really nothing that's changed, so I just want to update this video. In fact, there's a new textbook, and definitely look it over. IDS is important, and there's some really good stuff here. So, in any case, I'm going to splice into my previous video and call it my new one. The chapter talks about the OSI model, and the OSI model itself. I'm going to try this out here. So just look up. The OSI model itself is a great place to start when looking at security. And more than just for network-wise, I mean, really just in security in general. Everything from physical, right? So here we can see our physical layer. Well, think of physical security, right? So we have the best server in the world. It's hardened, it's patched, monitored, but it's in a closet that no one has key. It's just an unlocked closet. Or who has the keys to the server room? Who has access to those keys, and so on. So data link, that too, right? How's our wiring look itself? Our network wiring, our packets, all that stuff. How's that being sent around? As you move up the stack here, you come from looking at the physical security of a device to how it's connected, and not just connected in forms of malicious, but also, do we have backup networks? Do we have a failover? Don't forget, a big part of security is not just can I defend myself, be resilient from a hacker, can I be resilient from any forms of risk? So, especially high levels of risk. And so, our network configuration, things like that. And then we look at our, we're using TLS, right? When we get into here, our transport, we're using, transport layer security, HTTPS, SSH, as our MIME transports, all kinds of stuff, FTP secure. How those look actually look out there on the network too when they're being looked and exposed. How can we see this? Is it fully mappable from external or not? So again, our data, most important, right? How are we protecting our data? So we saw before in previous one how we handle sessions. It's not in-house communication. How's our session management handled? So is it being properly done where we can't get any horizontal or vertical escalation attacks? So up the chain here, these last two, application, code. How's the code of our application? Does the code go through any kind of validation process? So this model, you could take this and really stretch it out and look at a security stack, not just from the network in all aspects. So, in case, keep that in mind. It's a great way to approach this. This talks about it more on the network side, but I like to bring it to you as look at this from a model for cybersecurity in general and resiliency. So, devices. So we have tons of kinds of devices on the network, and really, what are we doing with these devices? Are our bridges? First off, what are the devices? What are they? Understand what they are. where they operate on that stack. Are they layer 2? Are they layer 3? Are they multi-layer devices? Switches is probably going to be the first thing that's really going to come to mind. Hubs, I mean, besides maybe for very small homegrown networks, hubs, of course, we know are not very scalable. They're not managed, and really they can just they become really an issue upon larger implementations of hubs. But switches, which you can buy now, are like super cheap, little managed, unmanaged switches. So when it comes to larger corporations, large institutions, you're probably gonna have managed switches. How they manage. So I'm going to talk about how a switch works. I'm only going to breeze over these, but understand that's probably going to be your main stops for looking at security auditing and security of a network. Same with your router also. So our next thing is our router. And not just your network, think of the cloud too. That's where this last one comes in. Load balancers. Load balancers are very critical for the availability part. Remember our CIA? Not the CIA as in the people in Langley, Virginia. I'm talking about CIA confidentiality, integrity, and availability. Availability, load balancers. I mean, that's it right there. So we see this with cloud a lot because the cloud you can scale up and bring in not just load balancing. You can also fire up servers as needed for capacity. So to really keep that pillar of availability up and running, there's a lot of stuff the cloud has to offer, but also even non-cloud. Let's say you still run your own data center. Load balancers, are they being used across the network in proper locations? And are they secure? So routers, again, layer 3 routers. Routing is definitely going to be a huge part of our traffic. So there's different types of load balancers. Some are going to do like layer 4 are going to be transport layer based. A lot of times you're going to have like a rule of 3 on here, like round robin. So every other server will get one. Maybe you have 5, so 3 with a backup, and then a hot spare, things like that. There's different concepts here with architecture. Layer 7 that might be application based. In other words, if when that session gets tied to a server, that session always goes to that server. So there's affinity, other types of stuff. Round robin is probably the most common one. Again, being a security professional, you need to be able to have your feet in different parts of areas. You're not going to be the expert, or maybe not. You might not be the expert in networking. I know I wasn't working at different places, but I knew how to talk to them and understand they had the proper stuff in place to handle availability, like for failovers. And also, I can talk to them about make sure they have certain things in place for auditing these devices, whether it be a load balancer or a switch. So, firewalls. I mean, firewalls. We know firewalls all. They're pretty much straightforward. The basic firewall is going to be looking at just your stateless firewall. So, stateless being, we build our firewall out, and so here's our ports. Ports 80 open and 443 is open, and so on. Let's say port 22 is not. We keep that one off. So, firewall. If I get a hit. If I get a hit for a login for port 22 from a specific IP address, a single IP, it will deny it, right? Bounce it off. Well, let's say they get another one. Deny it. They'll deny it. They'll deny it. Well, more of a stateful firewall might see this and say, or like more of an intelligent firewall, see this and go, well, I'm getting the same request over time from the same IP address. This looks like an attack, so I'm going to log an issue to it and maybe block that IP. So we'll see later here, firewalls are really going to become more of intrusion prevention devices also, especially when you get to more, again, these are larger scale firewalls that are managed. But we know the firewalls need to be in certain locations, right? Definitely maybe here's our DMZ. So between these two firewalls is our DMZ. We're going to allow 22 in to our server from internal. And then from the rest of the world here, we are not, we'll put that cloud there. So firewall placement is very important, and not just placement, auditing those firewalls and monitoring the firewalls. So those are the kind of things you can bring up when you look at auditing a network. So again, you can see here, you have firewalls also on your devices too. So you should not just have a firewall here, not just here. We should have firewalls at different layers. Probably here, we can have one at the segregation here, maybe one behind the switch. Again, and this is where the architecture comes into play. You want to be able to make sure you build it in early, or else it's going to cost more money to fix it later. And this goes to a lot of places of security, not just networks, coding, you name it, server design, and installation. So again, let's go over that. That's just talked about that. Stateless and stateful. Again, keeps records of the connection, makes decisions based on connection and conditions. So rule-based firewalls, again, more important firewalls in place. The idea being they're not static in nature. They can be configured. Application-aware firewalls too. So app firewalls are definitely big. If I have a web server stood up, I will maybe put a firewall around it, and maybe allow only certain predefined application signatures to come in. So only web traffic can hit my web server from a certain vector of my network, where maybe from another place it can come in. Also payload analysis. What is in my payload coming in? This is again looking at more of a stateful based attack. Someone's coming with an attack and they're trying to load a JPEG that is malicious in nature, and trying to load it into maybe a file part that allows JPEG. So not only do I want to maybe catch that, deny it on the file load, but also catch it at the firewall. So again, it's that multi-layer security approach. So again, our next device here is our IDS. Biggest thing here is this: IDS is come in all forms and fashions. You can get an IDS that you might have a network server, a security server maybe. You can install some sort of IDS software. To be honest, what you want to look at IDS is, it could be as simple as something that goes out to these switches and routers and firewalls and pulls the logs off them. And it can use open source tool like Splunk maybe, and it could generate and just parse logs and look for specific conditions and send out alerts and or reports based on those. This could be homegrown. This could be commercial. It could not be beyond software. It could be a rackable device that this thing actually gets traffic put through, and as part of our traffic routing, inline IDSs and so on, passive IDSs. The big thing here is you don't want to do any kind of IDS as much as possible. I don't want to run web parsing or file parsing on these devices. I want to move those files off, those log files off, and here. So IDS and auditing go very hand in hand, and that's what you can see here: out of band, in band. Different types. Biggest thing is this. So how it works. Intrusion detection. And here's the big thing right here: is it anomaly based, or is it signature based or behavior based? Anomaly based would be this. So on my network here, I get specific levels of traffic per day coming in, maybe of HTTP, maybe HTTPS. It's a web server. Maybe I do see a small amount of FTP. So this is my user traffic, and I can take this every day, and with capacity monitoring, I can say, hey, 0 to 24 for the hours of the day. This is what we typically see of this traffic type of HTTPS. So this is our normal peak hours, and this is stuff you want to know, not just for security, but for when we do system updates. When can we take a system down for one of our systems off the load balancer to do work? So there's off hours and stuff to look at. Not just days of the week, not just what day of the hours of the day. You can take that and look at Monday through Sunday, what days of the week. So maybe, of course, maybe Mondays shopping days. We do shopping. Maybe the weekends are when we see most of our traffic, and maybe Thursdays and Wednesdays are low. So these statistics are very, very critical, not just for managing your capacity, but also monitoring for the oddities to come out. So what if we see a huge spike in HTTP traffic during a time when we don't see it? So you might kick off an alert for that. So, and again, that's looking at anomaly-based, signature-based. Again, we have patterns in place of certain traffic types. Again, let's go back to our firewall. A rash amount of login attempts from the same IP address that fail. Maybe those login attempts have certain characteristics about them. Like the first password was 000 and then 0001 and 999. Right? That's like a very pattern-based attack. Not just that, we can also look at, again, people are sending in SQL injection, which you could get cross-site scripting. This type of traffic comes in and it can be analyzed. And then we see those signatures and we can block those. Behavior-based, again, this is almost like anomaly-based. This can be also based on action or program. This is really seen a lot of times on endpoint management. Endpoint being not just antivirus, but maybe anti-malware, anti-ransomware. Before something starts encrypting my files, I want to stop it. We also can see this sort of behavior we can look at for intrusion detection and prevention. So again, we have host IDSs, we have IDS on the hosts, and we have IDS devices. Like I said here, we might have on the host, off the host, homemade or specific software, on a device with other software, maybe a network server, or an actual rackable device, as you saw here, an actual IDS device. These come with costs, of course, not just upfront costs. There's ongoing costs, power, cooling, space, and it could be a monthly fee also for updates for these things. So as you look to bring IDS into a network, realize that there's going to be ongoing costs for these. It's not a one-time upfront thing. So, and it's very important to be able to talk to costs, because as a security professional, it's good to be able to understand that you don't have all the budget in the world, and people who do the budget, right, cut the checks, might say, well, we're going to budget $10,000 for this. You go, well, yeah, but there's an ongoing yearly fee of 12 grand. I think it's going to be unexpected. So have that information up front, and understanding costs can help you with that. IDS host intrusion, I'm not going to go here. Disadvantages, advantages, application aware. Again, I think I talked to this already. Okay, IDS, IPS. Intrusion detection system. Basically, think of this. It goes through this thing, it sees something go off, and it sends out an email or an alert or logs a ticket or one or more of the following things. It does that, and it waits for someone to come and step in and block that IP address or stop that traffic. An IPS will do that and actually block it also, based on the rules. So again, sometimes people don't like IPSs. There's that false positive that can happen, and anything that can stop regular flow of production, that can be customers ordering stuff, that can cost money. So IPSs can definitely be something that you need to make sure you test up front really well. So And then there's security information management products, these SIEMs. Again, these are rackable, costly, again, usually a rackable device, or it could be a software suite that runs on a device you might own, but it's going to be a third party provided. Think of it as IPS, IDS, log monitoring, auditing. Again, it's something that if security is really of a value, this could be do some cost benefit analysis on it. Yeah, it's great to roll your own, Splunk based Python parsing, but it's a lot of money to get it running correctly, and it might not have everything you need up front, where something like this might. Again, it's going to depend upon the security needs, but it's going to use something like this, and this is great right here. This is a really good thing. I like to bring this slide in because what we see here is a dashboard. And I can't say enough about how there's a lot of noise with security. As a security professional, if you can find ways to cut out the noise, that can be whether you can boil down a technical issue, a security issue, down to a more consumable format by someone who's not a security professional. It could be a developer, it could be a manager, a CFO who doesn't have any idea what a cross-site script is, or what a SQL injection is, but they just know that it costs money. Same with this. A lot of noise, a lot of auditing, traffic, issues, alerts. These dashboards can be great, and there's ways to do these too, homegrown, but what open tickets do we have? What unpatched systems are running? What ports are currently opened up and running and allowing traffic through? These dashboards are really going to be the cornerstone for a DevSecOps type of team. And being able to help produce these is going to be good. Understand how we can run them. Again, this depends on. This is alienvault.com. Looks like this is really going to depend upon the manufacturer or the developer of these systems. So again, it's going to cost money up front, but it could be of great value to have something like this up and running for especially a high security, high resilient type of institution. So architecture. All right, so again, I mentioned before, I mentioned it again here, if I mention it, you got to design it as early as possible. But really more important is creating these network security zones with segregation. So have not just beyond the DMZ, but also we saw DMZs here before. Our web servers are broken out from our database application servers with several firewalls here. So again, we have this DMZ in place. We have a way to segregate this traffic. This is of high, very important to be able to do this. Untrusted traffic, really, to be a high resilient, you should not trust any traffic at all. Make the traffic prove itself, even if it's coming from internal. I know a lot of these textbooks are going to tell you to build out a strong network edge, and you should. Network edges should be strong. DMZ should be in place. Monitored, managed, smart firewalls. But it used to be as traffic came in, if it was internal traffic, you didn't worry about encrypting it. You left it as is. I know Google's looking at this. Everything, even inside the house, is encrypted. Assume someone's listening to your network. And so, pretty important. So again, users of NATs. I'm not going to go with this. This is some back to previous classes you've taken, but to get to my class here, you've already had taken some basic networking stuff, how NAT works, and that's going to change with IPv6, but they are good to have. I want to get to this right here is segregation. So just a real quick point here. So yeah, beyond having our external firewall here, which we have a DMZ for. And there we have, of course, web server, email server, the appropriate boxes. Again, another firewall. And this maybe we have our DevSecOps type of servers, we have our office space, and so on. We need to break this down too further. So beyond just to have this ability to sort of watch traffic as it comes in, Inside the ring here, we need to also build out and segregate traffic. So not just maybe front office has its own traffic, its own subnet. Of course, our data center should have its own subnet, and in itself should have a firewall and a switch controlling who can access this. Maybe only a certain portion of my front office is allowed in through my firewall. So I use an IP range, for example, only certain IP addresses, or IP range from an internal IP set. If I have a guest network with a Wi-Fi, definitely want to segregate that, right? I mean, we know, and even them have their own separate firewall and only allow in maybe like 443 and 80, right? Only certain port numbers. It's supposed to be port number there. Very important to have that. Don't allow any guests willy-nilly access to your any network. And also, not just our data center, inside our data center, let's take this even down to a deeper ring here. Our data center itself. Maybe we have really critical systems. Maybe we have HVAC in there. We have HVAC systems. We have a set of boxes that help control HVAC, the heating and cooling, not just for our building, for our data center. So yeah, this is critical infrastructure, right? We make sure our servers stay cool, but also we have our things like our payment processing, our PCI compliant servers. You definitely want to have to segregate. We don't want HVAC servers talking to PCI. We do not want that. Why, right? Always ask why. And so it goes back to need to know, right? So need to access. And in PCI, maybe our PCI, we have then our HR systems. We don't want those talking to each other. So segregations, as you go deeper down, should really live in there. And your core switching is going to be a huge part of this. Switching is a big deal. And then really on top of this is this right here, VLANs. Virtual LANs, again, I don't want to get into this. I never was an expert with VLANs. I knew people who were on my team that were. So, but it's going to allow to create, stand up and break down these segregated networks without having to go in and install another switch. So really a VLAN capable switch, which you should be, as a large institution should have these, can create this virtually without having to go out and buy a second switch to only have HVAC on, and only have PCI on, and only have a switch for HR. We can buy 2 high-end switches, so we have a failover, and then of course don't need this switch here. So we have failover capability, and we can do all the virtual LAN inside there. So let's use something called a tagging protocol. Let's keep that in mind. And this is from, I don't know if this is in textbook or not, I may have added this, but the target attack, if target was properly segmented. So it looks like, based on what this research showed, target hack, target breach came from a side channel. So again, we had a vendor here, a third-party vendor, which needed to have access into our system, into our HVAC, into our data center. So loop through here. But this is not segregated correctly, or somehow there was a channel here. So they were hacked, which gave them access to our, in this case, I say our ZEM, target's data center. So segregation networks is key. So data loss prevention. So now, break it down even further. What is the heart of this network? What is the thing we're protecting? Our database, our data, right? Even though I'm looking back at that OSI GIF, data is key, right? That is what we want. We want to prevent our data. There's ways to prevent data loss prevention. Something called DLP. It can monitor what goes in and out of a company's network, and does content inspection. And so what we can do is we can look at the content going in and out. So let's say we see FTP traffic going out, and that's not uncommon. Secure FTP still. So first off, maybe it's going to a destination IP that we're not used to seeing. It's new. That could raise an alarm, or at least raise maybe not blocking the IP, but maybe raising an alarm. Or maybe we're seeing data copied to a local device. And that data itself, what is this content? Well, let's say if someone's copying, their work schedule or a PowerPoint presentation, that's okay. But let's say they're copying out a database extract that has in it sensitive data. So that content inspection could kick off an alert and probably, let me clear my screen over here, kick off an alert and block that. So again, who, what, when, where, why. So DLP agents on network storage, network storage, and an agent in applications can ask these questions: who's requesting it? Where's it stored? Where's it going? What is the data? Things like that. So, and we can build in some security with DLP to hopefully block. And this is, again, you need to plan for the exploit to happen, the injection to kick off, and the actual data breach to happen. You want to block that as soon as you can. And this is going to cost money. Yes, it definitely was. DLPs are going to cost money, but if we can block that data breach, and I know some executives are like, well, no, if I pay all this money, I should have a data breach. Plan to be hacked. So this is huge in defense. It's called resiliency. You want to build in the ability at several layers to be resilient and stop or minimize the risk. And the risk of data loss is huge, so we can minimize how much data got out. So that covers why I think the chapter 6 is important to cover. Again, look over your chapter summary. Probably some details in here I didn't talk about, specifically with the different layers, the different types of stuff. Mail gateway monitor, I didn't talk about that. So look it over, and that should fill in some extra stuff that will help you get through things like the quiz. One last note here: if this week's hasn't changed, it probably hasn't. Don't forget, as you do any kind of labs, and the time of this recording, this is the lab for this week, which is identifying and analyzing a network-hosted intrusion detection system. So IDS stuff here. Going to be running a couple of Snorbeam, these different tools. Don't forget to look at the lab setup. I know it's easy to scroll through this. Most time lab steps is what? Log into Kali, log into Security Onion, and then go and do it, right? Well, you can see here in Security Onion, we're going to do a sudo service NSM start. Again, this is a terminal command, it's a Linux command. Sudo superuser service command. Service name is NSM, and the command to do it is start. Is to start that service. If you don't do these type of steps, it could cause some issues with the lab. So, just a note there. I want to bring up during this lecture here. I know it's a net labs thing, and these labs could change in the future. So, if not this lab, any future labs, please be sure. Just a reminder: always look at any kind of lab setups, no matter what they are, and to be sure that you can do the labs properly. So anyways, hope that's it, and that wraps up the topic. Thank you.